Hello student, today we are going to talk about the second chapter, class 10 polynomials. Okay, so you know that chapter 1, first chapter, I think we have already done almost all the questions regarding the first chapter. So uh, today we are going to talk about the second chapter, that's polynomials. And when you introduce this topic, you know that in class 9 also we have done some basics questions, basic concept about polynomials. Now in class 10 also we have one more times the same chapter, but in some elaborate way. So today, in today's lecture, today's videos, I am going to give you some basic concept about polynomials, so that uh, further it will help you to solve some question easily. So let me start from definition of polynomials. So what do you understand by polynomials? So it can be defined like this: any algebraic expression. So remember, any algebraic expression having non-negative integer as power of variables. So this definition means, so you can take any algebraic expression, but the condition is that the power of variable should be non-negative integer. So it may be positive integer, it may be 0, it's okay, but it should not be non-negative integer. So I'll give you some example. Let me write some polynomials. So 3x plus 5. So this is a polynomials. If you see this one, here x is a variable, and these numbers, they are called coefficient. So here 3 is coefficient, 5 is coefficient, but x is variable. Let me write another polynomials also. X square plus 2x plus 1 more polynomials, x cube minus x square plus 1. So if you see these polynomials, one thing is common. So that is, here power of x is 1. So I'll write here 1. Here power of x is 2. I'll write here 2. Power of x here 1. And there is no x term here, so you can assume power of x as a 0. So here power of x is 3. Here 2. And again here there is no x term, so you can assume power of x as a 0. So in fact here also you can assume power of x as a 0. So if you see all these polynomials, the common is that their power of variable, that is the power of x, will be either positive integers or 0. They never become negative integers. So let me write one more algebraic expression like this. If I write 3x to the power minus 5 plus 1. Now there is a problem. So since here the power of x is minus 5, which is non-negative, which is negative integer, so this is not regarded as a polynomials. So from here what you have understood is that to become a polynomials, the power of variable should be non-negative integer. That is, it can be 0, it can be positive integer, but it never's negative integers. If it is negative integer, definitely that algebraic expression is not considered as a polynomials. So another important concept you should learn is that degree of polynomials. So what do you understand by degree of polynomials? So here you can see I have written what is degree of polynomials. It's like this: the highest power of variable in a given polynomial is called its degree. That means, suppose you are given a polynomials, so you just check the power of variables. The highest power of variable is considered as its degree. So I am going to write some polynomials here, and So we'll understand what is degree from these polynomials. 5x plus 3 x square plus 3x minus 4 3x square minus 5x square minus 11x minus 3. One more, 2x power 4 minus 3x cube minus 3x square plus 6x plus minus 2. Okay, so I have written the 4 different polynomials. Now if you see the first one, here what is the power of x? That is 1. If you see the second one, actually the x is 2 times, so here x square and 3x, there x is 2 times, that is variable is repeating 2 times, but it doesn't make any difference. We should look the power. So power of x is here 1, here 2. So which is the highest power here? Among 1 and 2, definitely 2. So actually this highest power of a polynomial is called degree. So you can write here degree of this second polynomial is 2. Why? Because we have 2 power of x, 1 and 2. Among this one, 2 is highest, so degree of that polynomial is 2. Let's come to third one. So here also we have 3 different power of x. Here power of x is 1, here 2. Okay, I was wrong here, it should be 3 here. Okay, here power of x is 1, here 2, here 3. So among 1, 2 and 3, 3 is the highest power of variable. So degree of this polynomial should be again 3. So similarly, if you see the last polynomials, you will have 4 different powers. Here 1, here 2, 3 and 4. Among these, 4 is the highest. So the degree of this polynomial is 4. So I left number 1 question. So here, since there is only 1 times variable, so here degree is 1. So this is the concept of degree. So let me conclude like this. You may be given any polynomials, no doubt, but you should always look for the highest power of variable. That highest power is nothing, it is called degree of that polynomials. So if you understood the degree of polynomials, it helps you to understand some more concept about polynomials in further videos. Okay, let us understand the different types of polynomials. So that means polynomials can be classified based on the basis of their degree. So here I have written the 4 different types. So beside this one, there are more types of polynomials, but I am not going to discuss all this out here. So let's see first one here. This is your polynomials and degree is 1. You know it, how to find out the degree. So degree 1. And those polynomials whose degree is 1, they are called linear polynomials. They are called linear polynomials. And the polynomials having degree 2, they are called quadratic polynomials. Having degree 3, cubic polynomials. And similarly, having degree 4, they are called biquadratic polynomials. So that's why I was telling you that degree is a very important concept in polynomials, as it helps to classify polynomials as well as it helps to find out the zeros of polynomials also. Okay, let's do some questions. Actually, this is the first type of questions which is in your book in this chapter. So these questions is like this. Look here. The graph of y equals to p of x are given below. For some polynomials p of x, find the number of zeros of p of in each case. So that means you are given the graph of different polynomials in different graphs. So you need to find out how many zeros these polynomials have in each graph. So now how to do this kind of questions? So let me tell you. So how to find out the number of zeros? Here, see, number of zeros you need to find. So you just look at the x-axis. X-axis means the horizontal axis. X-axis. This is the x-axis. See here, x-axis, and the graph of polynomials is this one. See, this is the graph of polynomials. Here it is a straight line. So here it is a curve. Okay, this is the graph of polynomials given here. So this is the graph here. So this one you can see here, and you can see also here. Now we are finding the number of zeros of polynomials. See, you just see how many times the graph of polynomials cut or touch the x-axis. Again, I'll repeat. How many times the graph of polynomials cut or touch the x-axis, that will be the number of zeros of the given polynomials. So you just see the first graph here. So this is the graph of polynomials. It is nowhere touching the x-axis, nowhere. It goes straight this way, it goes straight this way. That means this graph of polynomials never touch x-axis. That means these polynomials do not have any zeros. So you can write here the number of zeros is 0. There is no any zeros. Okay, let's come to second graph. See, this graph, okay, going this way, it cut the x-axis one time here, and it never going to cut it again. So how many times it cut the x-axis? Only one time. This is the point where the graph cut the x-axis. So here the number of zeros is number of zeros this polynomials can have is 1. So let's come to third one. So here, so this graph, okay, cut x-axis here one time, again the second time. So how many times here? One time, two times. So these polynomials can have 2 zeros. So here number of zeros this polynomials have is 2. Fourth one, okay, it must have many zeros. Let me see. So it's going like this. It got one time here. Don't look at y-axis, okay, just look at x-axis only. One time, your 2 time, your 3 time, your 4 times. So this graph of polynomials cut x-axis 4 times. So number of zeros is 4. Actually, we are going to find out number of zeros in the question itself. Number of zeros equals to 4. So last one. So 1 time, 2 time, 3 time, 4 time. Yes, again it also have number of zeros 4. So I think you have understood how to solve this type of question. Best dear student, now for today, so we are going to close this video here only. So in next video I am going to talk about the continuation, that is for the zeros of polynomials, how to find out zeros of linear polynomials, quadratic polynomials, all these things. And regarding the different types of questions, so I will give you some practice question in WhatsApp. So you just go through WhatsApp, and regarding this video I want to tell one thing to you all. So please see this video 1 time, 2 times, 3 times as your wish if you get the time, but just make the habit of making notes by pausing the video. You can pause, you can make a note. So if you make a note simultaneously, then it's better, it's very easy to understand for you. So I hope you are keeping well. Let's meet in next video. Good luck.